Good afternoon, students. Welcome back once again to the mathematics class. In the last class, we have seen up to exercise 7.10, that is nothing but substitution method, that is evaluation of definite integral by substitution method. So already we have solved. It is up to exercise 7.10. So next we are moving towards some properties of definite integrals. So let's see the properties one by one. Here we list some important properties of definite integrals. With the help of these properties, we can evaluate definite integrals easily, right? So let's see first property. Property 1, it is integration a to b f of x dx, which is equals to integration a to b f of t dt, right? Next, second one, in words we can write it as, let's see, in words, if the variable if the variable changes but the limit and the function remain unchanged, so then there will be no change in the value, no change in the value of definite integral, value of definite integral, right? So let's see the property one. What we have, integration a to b f of x dx, which is equals to integration a to b, the variable x can be converted into t, and the derivative with respect to x is there in LHS, and in RHS what we have with respect to dt. So if the variable changes but the limit and the function remains unchanged, then there will be no changes in the value of definite integral. For example, integration 0 to pi by 2 sine square x dx, which is equals to integration 0 to pi by 2 sine square t dt. Just what you have changed here, you have changed the variable x in terms of t in the limit function as it is. The variable changes but the limits and the function remain unchanged, then there will be no changes in the value of definite integrals, right? It's the first theorem, that is first property. Next, second property, this property number 2. Second property is nothing but integration a to b f of x dx, which is equals to minus of integration b to a f of x dx, in particular integration a to a f of x dx. What we get here, the first fundamental theorem, which is equals to 0. So in words we can write it as the value of an integral the value of integral changes in sign if we interchange limits. So the value of integral changes in the sign if we interchange the limit. So let's see here. A is a lower limit, B is upper limit. So in the RHS, the limit has been interchanged. In place of B, we have written A. In place of A, we have written B. So the sign of an integral changes. Right? For example, integration 0 to pi by 2 sine cube x dx, which is equals to minus pi by 2 to 0 sine cube x dx, right? So when we interchange the limit functions, that is upper limit, lower limit, then the sign of an integral changes. Next, property 3. Third property, integration a to b f of x dx, so which can be splitted into integration a to c f of x dx plus c to b f of x dx. So let's see here, integration a to b f of x dx plus integration a to c f of x dx plus integration c to b f of x dx. For example, integration of 0 to pi sine square x dx, which is equals to 0 to pi by 2 sine square x dx plus pi by 2 to pi sine square x dx. So we are splitting 0 to 180 in terms of 0 to 90 plus 90 to 180. So next property, that is property 4. Fourth property, integration a to b f of x dx, which is equals to integration a to b f of a plus b minus x dx. So it is also same here also. A to b can be converted into in terms of x, we are writing a plus b minus x. So next property 5, integration 0 to a f of x dx, which is equals to 0 to a f of a minus x dx. So note that here it is particular case of what? Property 4. Note that P5 is, its property 5 is particular case of fourth property. Got it? 0 to a f of x dx can be written as integration 0 to a f of a minus x. So what we have here, a plus b minus x in property 4. What we are writing here, a minus x only. So next, property 6. 0 to 2a integration 0 to 2a f of x dx, which is equals to integration 0 to a f of x dx plus integration 0 to a f of 2a minus x dx. So what we are writing here for property number 6, integration 0 to 2a f of x dx, which is equals to 0 to a f of x dx plus 0 to a 2a minus x. It is fifth property. So next, property number 7. It is integration 0 to 2a f of x dx, which is equals to 2 outside 0 to a f of x dx. There are two cases. If f of 2a minus x equals to f of x and zero, two cases are there. F of x dx if f of 2a minus x equals to f of x, and 0 if f of 2a minus x equals to minus f of x. So next, property 8. In that first one, integration minus a to a f of x dx, which is equals to 2 times of 0 to a f of x dx if f is an even function, that is f of minus x equals to f of x when it is even function. Second one, integration minus a to plus a f of x dx equals to 0 if f is an odd function. F is an odd function, that is if f of x equals to minus of f of x, right? So these are 8 properties which are useful in solving, or you can evaluate the definite integrals easy by using these important properties of a definite integrals. With the help of these properties, we can evaluate the definite integrals easily. So let's see proof for this one. So first one, proof for first, it is P1. Proof for P1. Let's see one by one. So in the first proof, just it follows directly by making substitution of in place of C. Proof of first one property. Proof of first one. Let f of x dx, which is equals to capital F of x. So therefore integration a to b f of x dx, which is equals to f of x. Now apply the limit function after integrating. So which is equals to f of b minus f of a, and integration a to b f of t dt. After integrating, what we get? F of t is limit a to b, which is equals to f of b minus f of a. Hence what we have here? Hence we have integration a to b f of x dx, which is equals to integration a to b f of t dt. So next, proof 2 of a property 2. Let f be antiderivative of f, right? Capital F be what? Integral, or you can say antiderivative of f. Then by second, fundamental theorem of calculus. We have integration a to b f of x dx, which is equals to f of b minus f of a, which can be written as, by taking minus common, f of a minus of f of b. So which is equals to minus a to b f of x dx. Sorry, it's b to a. Integration b to a, minus sign is there, right? Minus of integration b to a f of x dx. Next proof, third one. In one more case, here we can observe that in the above proof 2 only, if a equals to b, what we can write then? In particular case, integration a to a f of x dx, which is equals to 0, right? So next, property 3. Again, let f be antiderivative of f. Then we have integration a to b f of x dx f of b minus f of a. Take it as equation 1. Integration a to c f of x dx, which is equals to f of c minus f of a. Take it as equation 2. And integration c to b f of x dx, which is equals to f of b minus f of c. It's equation 3. So adding 2 and 3, we have, adding equation 2 and 3, we have integration a to c f of x dx plus integration c to b f of x dx, which is equals to f of b minus f of, here f of c, f of c plus f of c minus f of c get cancelled. That is, f of b minus f of a remains here. So which can be written as integration a to b f of x dx. This proves what? Property 3. So next, property 4. It is property 4. proof of fourth property. So let t equals to a plus b minus x. Then after derivative, what we get here? dt. Here a is constant, b is constant, it is minus dx. So dt equals to minus dx. When x equals to a, t equals to what? T equals to b. And when x equals to b, when x equals to b, t equals to a. ax plus b minus x. So when x equals to a, what we get? T equals to b. When x equals to b, what we get? T equals to a, right? So therefore we have integration a to b f of x dx, which is equals to minus of b to a f of a plus b minus t dt. Can we write like this? F of a plus b minus t, because x equals to what we are getting here, x equals to a plus b minus t. So again, which is equals to interchanging the limit here, so sign changes. So f of a plus b minus t dt by p2 property 2. So again, integration a to b f of a plus b minus x dx by first property, just change in variable. Hence we have proof for this one. So next see fifth property proof. Fifth one. So here put t equals to a minus x. Then what we have? dt equals to minus dx. So just when substitute x equals to 0 and t equals to what? T equals to the substitute value here. X equals to 0, t equals to a we get. And when x equals to a, t equals to 0. Now let's see how we have solved in previous property, proof of previous property. Let's see similarly here also. It is integration a to b f of x dx, which is equals to minus of b to a f of a minus t. X value is what here? A minus t into dt, minus outside right here, dx equals to minus dt is there, so minus dt minus take outside. So now here which can be written as, by changing limit a to b, the sign changes, f of a minus t dt by second property, again integration a to b f of a minus x dx by property 1, right? So with this we hence proved fifth property also. Next moving to property number 6. Proof of sixth one. It is using property 3. Using property 3, we have using property 3 we have integration 0 to 2a f of x dx, which is equals to 0 to a f of x dx plus a to 2a. Just splitting the limits here, f of x dx. So let t equals to 2a minus x in the second interval on right hand side. Then dt equals to what we get here, minus dx, when x equals to a, t equals to a. Just substitute in this equation. When x equals to 2a, t equals to 0. Also x equals to 2a minus of t with respect to this, right? So therefore second integral becomes here what? T 0 to 2a f of x dx becomes 0 to 2a f of x dx, which is equals to, minus taking outside, that is dx, 0 to, a to 0 f of 2a minus dt into dt, minus outside is there. So by applying again second property, what we get here, a to 0 becomes 0 to a, sign changes, f of 2a minus t dt, and again which is equals to 0 to a f of 2a minus x dx. So hence what we have, 0 to 2a f of x dx, which is equals to 0 to a f of x dx plus 0 to a f of 2a minus x dx. So which is nothing but our sixth property. So next, seventh property, proof of seventh one, using property 6, it is previous property only, using property 6 we have 0 to 2a f of x dx, which is equals to 0 to a f of x dx plus 0 to a f of 2a minus x dx. Take it as equation 1 just by using previous property only, that is sixth property. If f of 2a minus x equals to f of x then 1 becomes 0 to 2a f of x dx, which is equals to 0 to a f of x dx plus 0 to a f of x dx, which is equals to 2 times of 0 to a f of x dx. And if next and if f of 2a minus x, which is equals to minus of f of x, then 1 becomes, that is 0 to 2a f of x dx, which is equals to 0 to a f of x dx minus 0 to a f of x dx, which is equals to 0. So hence we proved the property number 7 also. Next, finally, proof of 8th property. Proof of 8th one. So using third property, using P3, that is property 3. Let's see what we can write. We have integration minus a to a f of x dx, which is equals to integration minus a to 0 f of x dx plus 0 to a f of x dx. Then let take t equals to minus x in a first integral on right hand side, then differentiating, what we get, dt equals to minus dx. When x equals to minus a, t equals to, what we get here, x equals to minus a means t equals to a, and when x equals to 0, what we get here, t equals to 0. Also what we get here, also x equals to, we can write minus t equals to minus x, right? So now therefore minus a to a f of x dx, which is equals to minus a to 0 f of minus t. Just substitute the values in the first integral. Second integral as it is, 0 to a f of x dx, so which is equals to, just changing the limit, 0 to a, sign changes here, it is applying property 1 also, minus x dx plus of second term as it is, 0 to a f of x dx by property 1. Take it as equation 1. In that first case, we will see two cases are there. So now, if f is an even function, then f of minus x equals to f of x. So equation 1 becomes, let's see, f of minus x equals to f of x. So 0 to minus a2 minus a2 plus a f of x dx, which is equals to 0 to a f of x dx plus 0 to a f of x dx, which is equals to 2 times of 0 to a f of x dx. Next, second case, if f is an odd function, then f of minus x equals to minus f of x. Then equation 1 becomes integration minus a to a f of x dx, which is equals to minus 0 to a f of x dx plus 0 to a f of x dx. Here plus minus get cancelled. What we get? The value which is equals to 0.